So let's talk a little bit. I'm just going to go to a whiteboard here so that I can draw. And I want to talk to you a little bit about what the electric load looks like during the day, because it's really kind of interesting. Um, so if you're a power plant operator, let's just say, I'm going to draw a little graph here. Okay, so this is time during the day, and this is midnight to midnight. Okay, and this is my load. Okay, so my load's going to be in megawatts. That's the amount of power I'm producing. And what happens is, you're always having to generate some power. And so at midnight, people are going to sleep and it's cool outside. And then people wake up and they start turning on the lights and, firing up the microwave and the coffee pot. And your load goes up a little bit, and it goes up a little bit in the afternoon. And it's going to do this kind of thing. And then at night, it's going to go back down. People go to sleep and, it goes back down. So your load profile looks something like this. So this might be your load profile, say in the spring and the fall. It's not real hot outside. People aren't running their air conditioners a whole lot. But your load's going to look like this. And so say here in Jacksonville, let's say down here, maybe it's 1,000 megawatts I need to make. Okay. And maybe up here, my peak for the day, let's just say that was about 1,600 megawatts, okay? So somewhere, my base load, we call this the base load, the lowest that you need to generate, say somewhere around 1,000 megawatts. So you need to be able to generate 1,000 megawatts all the time. You need to be able to generate about 1,600 megawatts in the afternoon, okay? Now in the summer, so that's just spring and fall, when my electric usage is usually a little lower. So in the summer it might be a little higher. People wake up in the morning, they start turning on the AC and everything. But then what you see is in the afternoon, man, it starts getting hot. So people's AC, it's not cycling on and off anymore. It's just running all the time. And so you're going to see something like this, and then in the evening it starts to cool off a little bit, and it's going to go back down a little bit. Okay, but maybe my base load now in the summer, maybe it's like 1,300 megawatts, say. I'm just making these numbers up right now. But then in the afternoon, man, my afternoon peak might be 2,000 megawatts. Okay, so all of a sudden I gotta make a whole lot more electricity here than I do here. Right? Now, this is just for Florida, and specifically, I live in Northeast Florida, so I'm going to talk a little bit about what I know here. Might be a little different down south, or it might be a little different in places where natural gas is available. What happens in the winter, though, here in Northeast Florida, is that people are running the heat at night. They wake up in the morning, they go, man, the house is cold, and so they crank up their heat. And so what you see, and then in the afternoon, it's a little warmer in the afternoon and stuff, and people aren't quite as cold, and then maybe before they go to bed they turn the heat on again, and then they go to bed. Okay, so what we see in the summer and the winter is that my peak right here might be 2,080 megawatts, right? So I know that here in Jacksonville where I live, that the system peak, the most they ever have to generate, and it's actually it's a good bit more than 2,000 megawatts here in Jacksonville, but let's just for my example, I'm going to say, 2,080, right? So everybody starts their heat in the morning. They've all got electric heat, and because they wake up and they're cold, and so my peak is in the morning, and then it kind of tapers off because it gets warmer, and then maybe right before they go to bed, they go, oh man, it's cold, and they turn it back on for a little while. So, but your load profiles, they change over the course of the year, right? And the profile, of course, where the peak occurs changes over the course of the year. This is a winter peak here in Florida. This is a summer peak here in Florida when everybody's running their AC versus their heat. But as an electric grid operator, I have to be able to generate power to meet this demand, right? And so let's talk a little bit about how that's done. Because it's a pretty interesting problem. And again, I'm giving you all the background that you need to know to kind of understand why you need smart grids and what the drivers are, that there's real economic drivers for it. There's real money to be made and real advantages to our society and getting good at solving these type of problems. So you understand a little bit about load profiles here. and how that works. Okay, so of course, electric power, it has to be generated the second that it's consumed, and so you can't really store it, you can't really make it ahead of time. You have to be able to make it when you need it. So let's talk a little bit about how that's done, right? So you got different tiers of electric generation, right? And so you got your cheaper, cleaner, more efficient units, okay? So typically in the power grid, the cleanest, cheapest, most efficient power, it's all going to vary. And I'm going to say, I'm going to put these up here, okay? So this is kind of varied over the years because, typically the nuclear plants, a nuclear plant will be pretty large. So, you talk about generating units and you'll have, it's not uncommon to have generating units in the nuclear industry that are, in excess of 1,000 megawatts, which is, quite big. I think some in Jacksonville somewhere the average to peak power usage is somewhere around the 2,000 to 3,000 megawatt range. So this is quite a bit of power right here. Certainly 1,000 megawatts would power a city, 400,000 or 500,000 users probably. And again, you may go look that up on the internet and find out I'm a little bit off, but 1,000 megawatts is a big unit, So you might have this nuclear power plant, and it runs and it generates 1,000 megawatts all the time because they can always sell that power at some of the cheapest power on the grid. Coal plants tend to be pretty cheap, and a coal plant, this unit might be 650 megawatts. Sometimes they're bigger. I mean, you see at 800 or 1,000 megawatts, but somewhere around 500 or 600 megawatts for a coal plant is pretty reasonable. And then the gas plants, we're talking gas turbines here. We're talking about 150 megawatts, stuff like that. And we'll talk a little bit about gas turbines in a little while. But these days with shale gas and everything, gas plants are becoming some of the cheapest power in the grid. And so this is another interesting thing that happens in the power grid, is that let's say I go build a nuclear power plant, and I'm building this plant, and so I'm borrowing money. I'm floating a 30-year bond, say, on a nuclear power plant, and I'm going out and I'm floating a bond for a couple $1 billion. And I build this coal plant, or a nuclear plant rather, or I might borrow $1 billion and go build a coal plant. And again, I'm planning on paying that off over 30 years. Or gas plants tend to be cheaper, but still in the hundreds of millions of dollars that I'm borrowing here to go build a nice gas plant, a nice combined cycle gas plant. And so you make these huge capital investments, based on the assumption you're going to be able to run these plants and collect money for them and basically pay the loans on them. And the coal prices and gas prices and all that stuff have been very volatile especially over the past few years. And so there's a lot of coal plants out there that people built figuring that the coal plant was going to be the cheapest thing around, and now the gas plants are undercutting them, and so the coal plants aren't running. That's another problem that grid operators face, and that's a non-trivial problem because these are huge costs. I mean, you might still owe $500 million on your coal plant, and then you find out you're not running it at 650 megawatts all the time. That at night maybe they're taking you down to 400 megawatts because they don't need the load for what you can sell the power for. So that's the thing. Those are the things that kind of happen. In general, newer plants tend to be cleaner and more efficient. Older plants tend to be a little dirtier and a little less efficient. So, in your fleet, you've got the clean, cheap, efficient ones, and those are the ones you try and run. And if we go back to my old example, I talked about the base load, which is the lowest load you want to have to that you need to generate. And generally, that load's generated by the base, the cheaper plants. Those are the ones you run all the time. So what happens though is in your fleet, you're going to have your newer, cleaner, cheaper, better plants, and then you're going to have, older. It's usually older technology, a little dirtier. These days, even the older plants, you've probably had to put back-end equipment on it to clean them up, so they're not as dirty as they used to be, but they're not as clean as the newest stuff, and less efficient, right? So they're less efficient. And let me add something here: expensive fuel, right? Or more expensive fuel. Because here's another thing. So cheaper fuel. Here's the other thing: you go build this coal plant. Well, you might make a contract with a coal mine, and you tell this coal mine maybe they've got 20 years worth of coal, and so you say, okay, for the next 20 years, every month I'm going to buy so much coal from you, right? So you commit to a long-term contract, and they give you a pretty good price on the coal, and then you're locked in at that price. So in that case, you've tried to minimize some of your risk by locking in that price, but at the same time, when something like gas comes in and it's a little cheaper now, you've already committed to buying this coal. So maybe now you can't take advantage of the cheaper gas as much because you've got to buy this coal, you've got to buy it, and you've got to burn it. So, all things that go into the equation of operating an electric grid. We're going to talk about, so now, these are your base load, your base loaded plants. These are the ones that you do, these are the ones you run all the time. And then these are what we call peakers. Okay, so these are the ones that you start up, when your load looks like this, and then you go like that. These are your base load, and so this part is provided by your cheaper, efficient cleaner, and then this delta right here is provided by stuff that you're starting up in the afternoons, or you're running it low, really low load at night, and then cranking up in the afternoon to provide this peak. And so what happens is that this ends up being your cheaper power to produce. This ends up being your more expensive power to produce, okay? So, you have to price this into your price, and when you buy electricity from the electric company, let's say you buy electricity by the kilowatt hour. And these days, let's say in Florida, it's typical, say 12 to 14 cents per kilowatt hour that you're paying, right? Well, it might only cost like 4 cents up here to make it by the coal plant, right? Now that's just to make it at the power plant. That doesn't include, that's what the power plant's selling it into the electric grid for, or the gas plant or whatever. 4, 5, 6, 7 cents a kilowatt hour is probably where you're at here. Now some of these more expensive things, they might even be more than this. They might be, 16 to 18 cents a kilowatt hour, say. So you've got to blend this out where you're able to buy the cheaper power, mix it in with a few hours of the expensive power, and then also maintain your grid. These are all the things that you've got to work out if you're running an electric company. But the main point I'm trying to make here is that these peaks in the afternoon, these or in the morning, just depending on summer or winter, but these peaks are always provided by more expensive power, right? And so, if you can shave off some of these peaks, if there was a way that you could send information to your customers and say, hey, Mr. Customer, I'd really appreciate it if you would not run your AC quite so much in the afternoon, because that's going to prevent me from having to build a new power plant, or it's going to prevent me from having to start up this old dirty plant to supply that power for you to run that AC that afternoon. So, there's an opportunity right there. If you're a businessman, if you're an entrepreneur, there's a lot of money to be saved there. Because like I said, let's say that over time, here's your peak, and let's say your peak starts getting higher and higher. Well, eventually you're going to run out of these older inefficient units to run. You're going to get to a point where maybe this is as much as you can make, and that you're going to need to make this much next summer. And so you've got to build something. You've got to go build one of these plants that's going to require you to invest tens to hundreds of millions to billions of dollars to build it. And so, of course, the longer you can delay that, or anything that you can avoid making this huge capital investment just to meet this peak, saves you a lot of money. Okay, so there's a real economic driver to smart grid technology right there, and we'll talk a little bit about that. We'll talk some more about that in a minute, but